Good morning, everyone. How did everything go? Have any questions about the homework? Let's get going. Okay, can you please put your questions in chat? Okay. So as you gather your thought, I'll make a quick comment about your quiz, and then we proceed. So in the meantime, you guys, if you have questions, make sure you put them in chat. We go over them. So here we are. The question that gave you some difficulties is the graphing function. So I'm going to go through the graphing problem. Okay, here it was. So we had a function. I gave you a function, and the function looked like this. Something like that, and then it went down. That was the graph of my function. And I gave you some numbers here. I think that was 2 and a 4, and that was a 4, and this is -2. And the question is, sketch the graph of the derivative. It means how the slope is behaving. So under it, we have a graph, and here the output are the value that the slope is taking. The input is the function. All right. So we're going to do it step by step. -2. That's always, it was the derivative is 0 because the function is flattening down. So that's the slope. So right here, we had no issue with that. Before it, the function is decreasing and the slope is definitely negative, but getting less negative, heading toward -2. So it started by being negative from the bottom, less negative, heading toward -2. Is it in line, not in line? We don't really know. We have no idea. And then it starts being positive and getting more positive. It's not getting less positive. So it's getting more and more and more positive. Then something happened right here. What's happening right here? Right here, the derivative doesn't exist. Why the derivative doesn't exist? If I could take secant line to the right, the slope of those is 0. I take the secant line from the left, those slopes are definitely not 0. So right here, we needed an open circle to reflect the fact that the derivative doesn't exist. There is no tangent line here. And the reason there is no tangent line, because from the left and from the right, those slopes are different because they don't get close to a fixed number, which is going to be the slope of the tangent line. Now, between 0 and 2, okay, between 0 and 2, if I take any point here, the derivative is 0 because the slopes of the secant line is there is no change in the function. The function isn't changing. And the derivative is taking the change of the output over the input, but there is none here, it means this change is always 0. So from 0 to 2, it's an open circle because not derivative, and then up to here, the derivative is 0, absolutely 0. So it's right there. It's not, doesn't exist, it is a 0. Now we had issue at 2. At 2 again, slope from the left are 0, from the right, definitely not 0. It means there is no value, derivative doesn't exist. But after 2, okay, it's a straight line. So, and we know that if the function is a straight line, and then the derivative is nothing more than the slope of this line. Absolute, first it's negative, and it's the slope of this line. Now I gave you this point, and I gave you that point. And if you had computed the slope, you will get -2. So how will this be reflected on the graph? On the graph, it means right here, that's open because there is no derivative, and then it's straight line. It's straight line, and right here, it should be a -2. So that should be the graph of the derivative. Okay, so that's one of the problems that a lot of you had difficulties with, actually. All right. Now I'll go back to your question, and then we move on. So I have 21. I'll look at 21 first, and let's see what the difficulties were. So what is 21? Okay, so that's the basic quotient rule. So let us remember what the quotient rule tells us. So it's the derivative. So if you have actually f of x over g, and I'm finding the derivative. It's the derivative of the numerator times the denominator minus numerator, the derivative of the denominator, the whole thing divided by denominator square. Okay, so that's the quotient rule. So let's do number 21, which is a verbatim application of that. So I have the function f of x equal x over x plus 1, and I need to find f prime. Okay, so verbatim. That's the numerator. So it's the derivative of the numerator. So for now, I'm going to write x prime times the denominator minus the numerator times the derivative of the denominator, the whole thing times over denominator square. And now we do this, every one of them, step by step. So it's equal to derivative of x, it's a 1 times x plus 1 minus x times, what's the derivative here? Derivative of x is 1 plus 1 is a constant, the derivative is 0 divided by the quantity x plus 1 squared. Okay, so finally it's going to be equal to x plus 1 minus x over the quantity x plus 1 squared. And now the x and the x do simplify, and this would leave me with 1 over the quantity x plus 1 squared. Okay, so that's an application of the quotient rule that we're going to be using over and over now. All right, please, if you have any questions, let me know. Now I look at 69 and 92. Okay, 69. All right, let's see, what is it about? Okay, explain why or why not. Okay, that's a nice question. So first, it asks me, the derivative of e to the 5 is 5 times e to the 4. True or false? Back to you. True or false? True, justify. False, justify. False, false, because I don't want any more false. It's equal to 0 because it's a constant, absolutely correct. So this is absolutely false because e to the 5 is just a constant, is a number. What's e? E is 2.718. You raise it to the power 5, this is just a constant. it means that the derivative, so if we graph it, this function, if we graph it, we get that, a straight line. So the derivative has to be equal to 0. Okay. All right, B. The quotient rule must be used to evaluate the following. So we have x squared plus 3x plus 2 over x. And the question is, should we use the quotient rule? I mean, we can. Let me get that straight. We can use the quotient rule, but are we forced to use the quotient rule, or we can do this problem by avoiding the quotient rule, this particular one? So we can use quotient rule. That's absolutely fair because that's one function divided by another. But we must use it, or we can kind of not really necessary. What do you think? Because we're going to learn a lot of rules. I mean, actually, we learned a lot of them. We still have one major rule we have to learn. And a lot of time we ask ourselves, you know, do we have to hit it by this rule or by the other rule? So this one, okay, quotient rule. Can anybody else think of another way to do it? Ideas? We could divide each term by x and use the sum rule. Okay, so let's see what Elizabeth wants to tell us. So another way to do it is the following. Because remember, we can split the numerator. It means if you have a plus b over c, it's actually a over c plus b over c. So the numerator can be split. It's the denominator we have no control over. So what your classmate is suggesting, okay, this is, you can write this as x squared over x plus 3x over x plus 2 over x. So that's another way to do the problem. And if we simplify this tiny bit, we will get x plus 3x over x is a 3 plus 2 over x. But we know that this is 2 times 1 over x. And this is actually much simpler than using the quotient rule. So this would become the derivative of, I want to totally prepare it. That's become 2 times x to the minus 1. So I prepared the whole, so I rewrote it so I can find derivative now. And finally, let us proceed. So it's going to be equal to the derivative of x is 1. The derivative of 3 is 0. This is 2 times, that's the power. So it's the power x to the minus 1 minus 1. So that's give me 1 minus 2x to the minus 2. Okay, so which is slightly, in this problem, it's easier to use that than to use the quotient rule. Now let's do question number C. Oh, tells me the derivative of 1 over x5 is 1 over 5x4. Basically, true or false? Quickly. True or false? What did the student do when the student did that, actually? Well, I want all of you to answer. By now, I've memorized most of you. Absolutely false. Kiana, why false? What did the student do? When the student did this, what did the, first of all, they did not use any rule we've learned. Okay, so what did the student do actually? Okay, the student didn't study, didn't do their homework, that's for sure. And what they say is they say, okay, I'll take the derivative of the denominator, which is absolutely false. Exactly. Okay, they put 1 over the derivative of the denominator, which is absolutely false. I mean, we learned the rule because, of course, I don't show you where they come from, but we learned them, and that's the only thing we can use. We cannot make up anything. So now the way to do that is, again, you can use the quotient rule, but that's absolutely useless to use it. you rewrite as x to the minus 5, and this will become minus 5 x to the minus 5 minus 1, which give me minus 5 x to the minus 6. So they are trying basically to put in those problem every mistake that student tends to do. Okay, and here is the following. Okay, let's use another paper for that. So D is this. Okay, very typical mistake. And usually I don't blame the student when they do it, but then once I address it, I start blaming them. So this true or false quickly. All of you. Erin, Zach, Ryan, all of you. Grace, false, absolutely. Absolutely false. This is the product. And the product rule does not tell me the derivative of the first. That's what the student did. They took the derivative of x cubed, which is 3x squared times ex. Very typical mistake. It occurs a lot, but we shouldn't do it because it's wrong. So that's absolutely false because the product rule, because of the product rule, which tells me that it should be 3x squared derivative times ex plus x cubed times ex. That's what should be the derivative. Okay. All right, we'll look at one more problem, which is 92, and then we proceed. So number 92. What is it? 92. So suppose the line tangent to the graph of f at x equal to 2. So we have a function f of x. And then tell me that the tangent line at x equal to 2 is, so they give me the equation of the tangent line, is y equal 4x plus 1. And we have another function g, and the tangent line at x equal 2 is y equal 3x minus 2. Good. And the question is find equation of the tangent line of f of x times g of x. Very good. Okay. So before we do that, what kind of information can I get from here? So I have a function. And at x equal to 2, that's 2, that's the tangent line. So let us draw the tangent line. Let's draw the tangent line, not the function, the tangent line. It means if x equal to 2, y is 4 plus 2. So here this is x, and this is the 4x plus 1. So if x equal to 2, y is 9. So this is my 9. Okay, that's my 9. And the slope of this line is 4. So that's the slope. But that's the tangent line to the function. It means how is the function looks like. If this is the tangent line, the function is something like that. That's the function. This f. Okay. So what information does having the slope, the tangent line, give us about f? What kind of info I get? I'll ask you the question, so you know what I'm looking for. What is the derivative of f at 2? Back to you. Does this information tells me anything about the derivative of f at 2? back to you. So this line is the tangent line to the graph of the function at x equal to 2. What info does this give me about the function f? What is the derivative at 2? Remember the geographical interpretation of the derivative. Anybody? What's the graphical interpretation? What is f prime at 2 graphically? It's the slope of the tangent line at x equal to 2. That's really graphically the interpretation. So they did not give you the function, but they gave you the tangent line. So what information this gives me? This gives me that at 2, the derivative is equal to 4. So that's the first information I get. So f prime at 2, the derivative at x equal to 2 is equal to 4. This is because that's the tangent line. Another information it gives me, let me ask you, what is f of 2? Does this tell me anything about f of 2? That's the tangent line at this point. What does mean? What is f of 2? The value of the function at 2 has to be the same thing as what the tangent takes at 2. The tangent takes at 2 the value 9. It means the function itself takes the value 9. So that's really what this derivative is telling me. If I know the tangent line, I know the derivative at 2, which is 4, and I know the value of the function at 2. This is really the key things to get from that. Now I'll do the same with g, and then the rest will not be hard anymore. Okay, that's the hard part. Now find equation, g is another function. The tangent line at x equal 2 is y equal 3x minus 2. So what do we know about g? Let me pick another color. At x equal to 2, let's see, the tangent line at 2 takes the value 3 times 2, it's a 6, 6 minus 2, it's a 4. So it takes the value 4, and the tangent line has slope 3. So it's sloping a little bit less than the one before it. So my g of x now, my g of x is live right there. That's my g. So I only know how it is near the point 2, not more than that. So now let us actually use that. So what do I know about g? It's a nice problem, actually. At 2, g at 2, since the tangent line touches the curve at this point, so the value of the tangent line at 2 is the same as the value of the function at 2. So g of 2 is 4. Am I right? 3 times 2, 6 minus 2, 4. The derivative is the slope. So the derivative is the slope, and the slope of this line here is equal to 3. Okay, so this is what this information is giving us. Now I'm going to use those two important info to find the tangent line at y equal f of x times g of x. So let's do that quickly. So now I have a new function. We're going to call it's f times g. And the question is equation of tangent line at x equal to 2. Now, to find the equation of the tangent line, what do we need? So we need two things. We need a slope and we need a point. Okay, so what's the slope? To find the slope, let me call this h of x because I prefer function notation. Okay. So what do we need? We need two things for the equation. We need the slope, it means we need this, and we need the actual value of the function. These are what I need. Okay, let's find them one by one. To find h prime, I need h prime for any x. Once I find it for any x, I plug in 2 for it. So first we need to find h prime. What's the derivative? That's a product. So it's f prime times G plus F times G prime. Okay, so that's the derivative in general. So to find the derivative at 2, first I find it for any x. Now I zoom in at 2. What is h prime at 2? All right, now I need all the info I've collected in the previous problem. So what's h prime at 2? At this stage, I substitute. It's f prime at 2 times g at 2. I evaluate it plus f evaluated at 2, g prime evaluated at 2. Now I plug in the value. So it's equal to. So now I'm after the slope. F prime at 2 is 4. G of 2 is 4. Plus f of 2 is 9. G prime of 2 is 3. So the derivative will become 16 plus 27. It means 3 and 43. So the slope is 43. That's a huge slope. Okay. So that's give me the slope. Now I need the point. I need the point. But how do I get the point? So now the point is 2 h at 2. What the function takes at 2. All right, so what is h? Let's remember. H is the product. It's f multiplied by g. So at the particular point 2, now I plug in 2 wherever there is x. We're going to have f2 times g of 2. And now we finish. What is f of 2? Now I go back to my info. F of 2 is 9. Times, what's g of 2? I go back to my info. It's equal to 4. It's 36. Now I combine everything I know and I find the equation. So now I know the slope is this huge number, 43. The point is 2. And the output at 2, which is 36. And my equation become y minus 36 equal the slope times x minus 2. And you guys can finish the math. Okay, so it's actually, it's a nice problem. I kind of like it. It's a good exam problem. And so the idea is really to understand what do they mean by telling qy equal 4x plus 1 is the tangent line. What info can you get from that? What we can get the slope at this point, which give me the derivative at 2. And what I can get is actually the value of the function. Okay. Now the second part is exactly the same. I will skip that. I will let you guys work on it. So today we're gonna keep, of course, we keep going along the same line. It's actually kind of easy. Tomorrow will be harder, but today is easy. So section 3.5, derivative of trigonometric function. So 3.5, derivative of trigonometric function. It means the sine, cosine, and all those. So we start with the derivative of sine, and usually I will give you the formulas for that, but let's talk a little bit about it before I give you the formula. So the derivative of the sine function of f of x equals sine x. First, let me put one point that the unit here for the angle. So whenever you're talking about the sine, it means you're talking about the sine of an angle. And that's very important here, that the unit is in radian. Means the formula we were about to learn are only true in radian. That's why calculus work with radian, it fails with, doesn't work with degrees. Okay, so the only thing I'm going to do is This is my function sine of x. We're going to find the derivative at 0. So find the derivative of sine of x at x equal to 0. Okay, we're going to find this one only, and then we proceed. So let us remember, so this is my sine function. That's my sine. Let us remember the graph. It starts here, it goes up to pi over 2, it back down. This is a pi, it goes up, down, up, and then it repeats itself. And this is pi over 2. This is my pi, and this is 2 pi, and this one is 3 pi over 2. Okay, I just want to find the derivative here at 0. It means I want to find the slope here. What's the slope right there? That's the only one I'm going to go after. All right, so what is the slope? We use the formula verbatim. So it's the limit. It's a limit. The slope is a limit of sine. So since I want at 0, it has to be 0 plus h minus the sine of 0 over h when h goes to 0. So I'm computing those little slope. Now it is equal to the limit of sine 0 is 0. So this is equal to 0. So I will have the sine 0 plus h, so it's the limit of sine of h over h. Okay, this limit, the book tried to give it to show you how to find it. I don't care, we just do it numerically. It means we let h comes to 0 and we compute those values. So I make like a little table here, nothing more than that. I take h and I compute that. And I want h goes to 0, so from both sides, because we know we may have issues. So I will take few values, because 0.1 and minus 0.01. Okay, so I'm letting h goes to 0. And then I'm going to evaluate. I thought I did it a minute ago. Okay, so let us evaluate. So it's basically, I pick up my calculator honestly, and I compute those numbers, no more, no less. Granting the unit is radian, so it has to be radian. So let us do, actually I computed them. At minus 0.01, I got 0.99998. So at this is 0.99998. At minus 0.1, I get 0.9983. At 0.1, it's also 0.9983. At 0.01, it's 0.99998. So as it's very clear that as we take h very small, whether we go from the left or the right, the slope of the secant line are approaching a 1. Okay, so this limit is equal to 1, and that's the only value I want to. Now, if you, instead of using radian, you take your calculator and you put it in degree mode, and that's why things will change in degree mode. And you compute in degree mode, which is a totally different unit. I mean, radian is, degree is very, very tiny. Radian is much bigger. And you will not get a 1. You will not get a 1. You will get something, I think, 0.18. So if your unit is in radian, this will not be 1. It will be actually another number. And that's really why we use radian, because this one will play a role in here. Okay, so now let us graph the derivative. So that's the derivative of sine. We're gonna just graph it. I will not prove it. And that's the derivative of x. Right. So what's the derivative of sine? X is 0. X is 0. The derivative is 1. Is the slope is equal to 1. Which means when I come here, I'm going to sketch the derivative. At 0, I know I have a 1. And then what it does, it peaks here, it peaks here. It means at pi over 2, my derivative is 0. At 3 pi over 2, my derivative is 0. Okay, so just a good review of how we sketch the graph of the derivative. And then what's the derivative doing after that? Between 0 and pi over 2. It's positive, it's getting less and less positive, heading towards 0. So it's positive, getting less and less positive, heading towards 0 at pi over 2. Then what's doing after that? It's definitely negative. So the output here, the derivative right here, it's negative. And it seems to be getting more negative, but then at some point it changed, like around pi, it seems to change, and the derivative, the slope are becoming, staying negative, but less negative. So it seems to be wiggle like this, and then less negative heading towards 0. So that's really how the derivative. And now this is 3 pi over 2. And after that, it's positive, positive up to 2 pi. So at 2 pi, it is actually positive and goes like that. So that's almost like this. But then what it does after that? Since the sign repeats itself, the slopes are going to repeat themselves also. They're not going to change. So after that, the slopes are going to repeat themselves. So it's going to go periodic like before. So this is not a proof, this is just a picture. But what does this suggest? This graph here, does it remind you the graph of any function that you're really familiar with? I mean, just the graph, and nothing really deeper than that. If you look at the graph, it starts at 1, it is 0 at pi over 2, it is 0 at 3 pi over 2. It looks like the graph of the cosine function. And that's the cosine graph. And as I said, this is not a proof, but this is just a feeling for it. Okay. So this tells me that the first important rule here is that the first rule. Those, again, stuff like that you have to memorize. The derivative of the sine function, d dx of sine x, or for short, sine x prime, is equal to the cosine. Absolute memory. And if we use degree, this number is going to be 0.18. So this will not be really quite the graph of cosine if we use degree. That's why it's important. It's actually right here is going to be 0.18, and the graph, the derivative will be 0.18 times cosine. So it will not be cosine if the unit used are degree. That's why we scratch them and we only use radian in calculus. Now, what's the derivative of cosine? If we just use this picture, so forget about that. If this is cosine, and I'm going to sketch its derivative, actually, why use this? Let's do it. And then I'll go back to fill in this, this box. What's cosine? Again, I will not prove it, but just have a feeling. Let's see how the cosine work. The cosine, that's the graph of cosine. It starts here, go back, up, and then it repeats itself from both sides. That's how it is. So if I'm going to sketch its derivative, things will change. It's 0 here, so we are right here. And right here, we're at 0. But then what's happening now? Decrease, more, and then it's negative, getting less negative, getting less negative, heading towards 0. So the derivative is going to look, it's negative, negative, getting less negative, and then heading more negative, heading towards 0. So it's not the sine graph. And after that, it's going to be increasing, increasing, getting more positive, then it's starting to become less positive and heading towards 0. So it's going to become positive, 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 and then becoming less positive, heading towards 0, because the function is flattening it up right there, which is 2 pi. So it's not the sine. What's going to turn out to be, the derivative is going to be minus the sine of x. So it's not really the sine, it's the minus the sine. All right, so now we go back to the box. The derivative of cosine is minus the sine of x. Absolutely important, total memory of those derivatives. All right, now, so we have those. So let us do some simple application for a simple function, and then we do the tangent and all the other ones. So, for example, find the derivative of I think h of x equal something like sine x over 1 plus cosine. Okay, so that's my function. And the question is, find the derivative of this. All right, what do we see in here? How can I find the derivative of that? Quickly. I'm reading. How would you find this derivative? Okay, I want answers on chat. How do you find the derivative? Which rule do we use? That's the quotient rule. One function divided by another quotient rule. Okay, so let us use the quotient rule. Okay, so it's equal to the derivative of the sine function times, so the numerator, denominator, minus the numerator times the derivative of the denominator. The whole thing divided by the denominator squared. And let us compute this. The derivative of the sine is the cosine. That's where we have, as I said, memorized those. Times 1 plus the cosine minus the sine times. What's the derivative of 1 plus cosine? The derivative of 1 is 0. The derivative of cosine is minus the sine. The whole thing divided by that. Now the rest is algebra, and let's do the algebra. I will have cosine x plus cosine times cosine, cosine square, minus minus, that's a plus, sine times x is sine square over 1 plus cosine square. Okay. Now, can we do anything here? Can anybody see anything we can simplify? I don't know. What can we do here? Are we done, or we can make it look nicer? Anybody jump, anything jump to you? Where did you get the cosine square x from? This one? Okay, cosine times 1, that's a cosine, plus cosine times cosine, that's cosine square, plus minus minus plus sine square. Zach, is this your question? Zach? Is it? Okay, no problem. Now, question was again, can we do better? So one of your classmates tells me, you know, cosine plus sine, that's the most basic trigonometric formula I would like you to know, which tells me that this is equal to 1. Okay, so it's nice to use properties we have. So cosine squared plus sine squared is equal to 1. So this would give me cosine x plus 1 over 1 plus cosine x squared. Okay, so this could be simplified. Now I have this over that, so this would leave me with 1 over 1 plus cosine. Okay, so it's a verbatim application of the quotient. So now let us do the derivative of the other trigonometric function. And because there are application of chain rule, sorry, quotient rule and stuff like that. So the question number 2 is, we're going to find the derivative of tangent. So I'll pick another paper. Okay, so find the derivative of tangent. Question. So let f of x equal tangent x. And the question is, find f prime. Okay, do you think we can do that? Can we do that? What is tangent? So we have everything. We need to find the tangent. So let us remember what's the tangent. Tangent is the sine over the cosine. Okay, absolutely. And that's what we have to use. So what's going to be the derivative of that? All right, we use the quotient rule again. So that's the quotient rule. The derivative of the sine times the cosine minus the sine times the derivative of the cosine, and the whole thing divided by the cosine square. Sorry, this is the sine. So remember the quotient rule, there is a minus, and the product rule is a plus. So let us compute this. Derivative of sine is, the derivative of sine is cosine times cosine minus the sine times the derivative of the cosine is minus the sine. Okay, and the whole thing divided by cosine square x. Now, of course, we need to simplify a tiny bit because we need a formula that we should be able to memorize. So this will give me f prime of x equal cosine square minus minus plus the sine square divided by the cosine square. Okay, and now, as we all know, as we did it a minute ago, cosine square plus sine square, which is the basic trigonometric identity, which is follow from Pythagorean. If you have any angle x here, remember the sine is this coordinate, the cosine is the y coordinate, the sine is the y, and the cosine is the x. So if you take this square plus this square, it's going to give me the 1 square. So this is equal to 1. And this will be equal to 1 over the cosine square of x. So now let us summarize what's the derivative of tangent. Okay, so the derivative of tangent is equal to 1 over cosine square x. But a lot of time people don't use 1 over, they use, instead of using 1 over cosine square, they express this in terms of secant. So what's 1 over cosine square in terms of secant? You remember? It's secant square. This is secant square x. Okay, so the derivative of tangent is secant square x. Those, I know that we're learning online and you guys can look this up, but I strongly encourage you to memorize those. It's absolutely crucial that you memorize them. There isn't much I can do about it. Usually when I teach face-to-face, the students take all their quizzes basically without a calculator and closed book. I cannot do that now, but I strongly encourage you to memorize because you're gonna need this stuff all the time. Okay. So let's take care of tangent. Now I can play the same game and I can find the derivative of secant, which is not hard because, actually, why don't we do that? Let us find the derivative of secant. I will comment on that, Neely, in a second. Yeah, it's a good question. Okay, actually, I'll comment on it now. Cosine squared, that's a notation. That's a notation, which means this. Okay, that's a notation. This is the meaning of it. It means you take the quantity cosine x and you raise all of it to the power 2. So that's the notation, which means that. Okay. So let us find the derivative of secant, because that's another one of those that, again, you need. All right. So let us find secant. What's the derivative of secant? Secant is 1 over cosine. So it's basically, I'm finding the derivative of 1 over cosine. All right, how can I find the derivative of 1 over cosine? How can I do that? This is one function divided by another. We're going to use the quotient rule. So what does the quotient rule tells me? The derivative of the numerator times the denominator minus numerator, the derivative of the denominator, the whole thing divided by the denominator square. Okay, and now let's do that bit by bit. The derivative of 1 is a 0, so I will have a 0 minus. The derivative of cosine is the minus sign divided by cosine square. Okay, because this means that. So it will be equal to minus minus is a plus. So I will get sine x over the cosine square. All right, so that's the derivative. Now you can memorize it this way, but usually it's not memorized this way. It's memorized like this. So it's sine x over, so that's now how we memorize it. Cosine square is cosine x times the cosine of x. Okay. And now I'm going to split it this way. I'm going to rewrite it as sine over cosine times 1 over cosine. So I'm not really, we're just playing games now, because to give you the format that those derivatives are memorized by it. Now sine over cosine, that's the tangent x. 1 over cosine is secant x. Okay. And now we have the derivative of the other basic functions. So we have sine, cosine, tangent, secant. And then, okay. So I had a box here for those that you have to memorize. So derivative of tangent is the secant square. Derivative of secant is secant tangent. Right? So, and then we have the cosecant and the cotangent. So cotangent x is derivative. You can play the same game. It's cosecant square. So it's the same game that we played. And finally, the derivative of cosecant, which is play the same role. Sorry, there is a minus in here. And finally, the derivative of cosecant x, and then I go back to the question addressed on here, which is instead of secant, it's cosecant, instead of tangent is cotangent. Okay. The one we use the most, at least in here, are sine, cosine, of course, tangent, and secant. A bit more than those two. All right. So I will go back to the question that's addressed there, and then I will go down so you guys can copy. So I'm finding the derivative of secant. Secant is 1 over cosine. And we use the quotient rule. The derivative of 1 times cosine minus 1 times the derivative of cosine. 1 is a constant. The derivative of 1 is a 0. 0 times cosine is giving me a 0. Minus. Derivative of cosine is minus sine divided by cosine square. So if the question addressed what happened to this cosine in the numerator, it's 0 times the cosine, which giving me a 0. And then after that, minus is a plus, so that's a sine x over cosine. And at this stage, I start splitting. That's where we start playing games. We wrote this as cosine times cosine, and then it's sine over cosine times that. So that's property of fraction. We multiply numerator, multiply denominator, we get this one. And then at this stage, sine over cosine became tangent, 1 over cosine become bisecant. All right? So that's how it went. And then these are the rules that we have totally to memorize for that. All right. Okay, so that's it for today. Please do your homework for tomorrow. I'll put it on my lab in a second. So, and if you have any questions, join me in my office hours. Okay, bye for now.